you guys, so today we're going to go ahead and finish up those notes over section 2.1 that we started yesterday. Remember, download the PowerPoint. I know the lighting is not always awesome in here, but hopefully you can see that PowerPoint at home. Here, let me try to adjust my lighting. Yeah, okay, so here's this example that we were working on yesterday. We found our quadratic equation in vertex form of this graph. So we just need to work on going from vertex form to standard form. So yesterday we found our vertex form was negative 16 x minus 1 squared plus 20. So to go from that into standard form, which if you remember yesterday, standard form is f of x is equal to ax squared plus bx plus c. So to go from something like this into something in this form right here, where we're going to have a number and then x squared, a number and then x, and then a number in c. Let's see. Okay, I hope you guys can see. Sorry, let's try that. Maybe that'll be better. Okay, so to go from there to there, what I'm going to do is this x minus 1 squared, that just means I have two quantities of x minus 1. So I would have negative 16 times x minus 1 times x minus 1, and then I still have that plus 20. So what I want to do from here is I want to FOIL this together. So I would take my x times my x, so I'd have x squared, and then negative 1 times x, which is going to be negative x times negative 1, which is also negative x, and negative 1 times negative 1, which is going to be positive 1. Now after I FOIL that, I can go ahead and combine my like terms. So, but I can only combine what's in the parentheses right here, because I'm going to have to distribute this negative 16 into these numbers. So I don't want to combine the 1 and the 20 yet, because I'm going to have to distribute first and then combine the like terms. But I can combine the ones that are in the parentheses. So I can combine the negative x and the negative x. So I would have x squared minus 2x plus 1. Now this expression right here, I can go ahead and now distribute my negative 16. So I'd have negative 16x squared plus 32x minus 16 plus 20. Now the very last step, I can combine the 20 and the negative 16. So I'd have negative 16x squared plus 32x plus 4. And I'd have f of x is equal to that. Okay, so this would be my equation. It's the same exact equation, but here it is in vertex form, and then here it is in standard form. And now you can see it looks like the ax squared plus bx plus c, because I have negative 16 for my a, and then the x squared, 32 for my b, and then the x, and then 4 for my c. Okay, so that would just be going from vertex form to standard form. Okay, so one last example. This one I have another graph. I'm going to go ahead and write my equation of this graph, and we'll practice vertex and standard form. Okay, so the vertex form, I'm over here at 2, 10 for my vertex, and then it also gives me another point at 0, 4. So we're going to use that other point in the vertex to help me find my a value. So to start off, I have to start with vertex form. I can't just jump and like go to standard form. I have to go to vertex form because I have the vertex point. So vertex form we know is f of x is equal to a x minus h squared plus k. So now my vertex coordinate, the 2, 10, always goes in for my h and my k. And remember, it's always opposite of the h, so because it's at positive 2, I want to put a negative 2 in here. So I would have x minus 2 squared plus my k value, which is 10. So now I plugged in my vertex coordinate, and now I can go ahead and use my other coordinate at 0, 4. And the 0, 4 I can plug in for the x and the y. So the 0 will go in for my x. And then the 4 is going to come over here for my y. So now that only leaves me with the a variable. So now I need to go ahead and solve for a. So first I start by doing what's in parentheses. So 0 minus 2 is going to give me negative 2, and that's squared. Negative 2 squared is going to be 4, so I would have 4a plus 10 is equal to 4. Now I'm trying to get a all by itself, so I can go ahead and subtract 10. So I have 4a is equal to negative 6. Divide by 4, and I'm going to get negative 3/2 when I simplify that is equal to my a. Okay, so now I need to go ahead and just write that equation. So my vertex form, I'm just going to take this a value and I'm going to plug it back in for a. So I would have for my equation f of x is equal to negative 3/2 x minus 2 squared plus 10. And then remember, you guys, you always need the x and the f of x or the y when you're writing your equations. You need those. Don't have the numbers, the 0 and the 4 plugged in when you're writing just your general equation. So it should look just like this. Okay, and then now to go from vertex to standard form, if I break this quantity, the x minus 2 squared, I can go ahead and break it down and have x minus 2 times x minus 2. Now from here, I can go ahead and multiply. I'm going to FOIL within my parentheses. So x times x gives me x squared. Negative 2 times x gives me negative 2x. X times negative 2 gives me a negative 2x again. And negative 2 times negative 2 gives me positive 4. Now that quantity is going to be distributed the negative 3/2 to it. And I'm going to do that before I add my 10. Okay, but before I even distribute, I can go combine this negative 2x and negative 2x. So I'd have x squared minus 4x plus 4, and that's going to be multiplied by negative 3/2, and then I have the plus 10. So now if I take negative 3/2 times x squared, I would have negative 3/2 x squared. Negative 3/2 times negative 4 is going to give me a positive 6x. Negative 3/2 times positive 4 is going to give me a negative 6, and then I have this plus 10. Now if I combine my negative 6 and my positive 10, I'm going to have just 4 over there. So my equation is going to end up being f of x is equal to negative 3/2 x squared plus 6x plus 4. Okay? So yeah, so that is everything from the first section. We talked about just like how to graph quadratics, how to write them in vertex form, and now you guys know how to go from vertex to standard form. If you have any questions, make sure you just let me know. All right, bye guys.